And welcome, students, as we dive into the next review lesson. Let's quickly do a recap of inheritance and polymorphism. So if you recall, this is the big section that we talked about on derived classes. Now, I'm not going to give you too much notes on some of the stuff because a lot of the stuff is kind of just some of the more theory-based stuff and not so much the coding side of it. I'll put a couple more examples up into the notes just so you have some reference material because I think those are actually going to be more useful to look at than just a series of notes all over again. But if you recall, Java uses two things. They have what's called base classes and derived classes. So like a parent and child relationship. Now the derived classes can inherit all the methods that the base class has, but not the other way around. Derived classes are, of course, indicated using the extends keyword. So say like, if we look back at our employee class that we had once upon a time, we had like hourly employee extends employee. Derived classes, of course, can use the superconstructor to inherit constructor parameters from the base class. So, for example, public hourly employee string the name, date the date, double the wage rate, double the hours. We can say super the name, the date, and what it will do is it will pull how those variables are used from the parent class. We also want to remember that Java, the way it functions in its method assignments is through late binding. So with late binding, this is where our method definition that's associated with the method invocation, it is assigned all that stuff when the method is actually invoked at runtime. So it doesn't do it, first, like when it goes to compile the message and stuff like that. It's going to do it at runtime, which means it's going to do its stuff first and then try to assign things. You can, of course, do other things with methods. If you remember, if you mark it as final, you're going to indicate that that method cannot be overridden with a new definition within a derived class. Because a lot of times, if you want a method to remain unchanged, you can just put it as final. So I can't go and override that in my derived class. Because remember, in the derived class, I can take a method and change what it means. So also a very important thing, since we're talking about overwriting, are things such as the equals and toString method, and of course the object class itself. If you remember that pretty much all classes should pretty much use the equals and toString methods, largely because if we need to do any kind of object comparison, we're going to need equals. ToString, of course, is also used to convert the object values to a string because, if you have, like, for example, like a date object, you can't just system.out.println date 1. You can't do that. You'd have to do a system.out.println of the date object variables inside the method using toString. So a very important thing to kind of keep in mind. However, when using derived classes, I see I forgot using, you may have to modify your equals and toString methods to have them fit the new class, especially when we start getting into derived here classes. Base classes is not so much an issue, but derived classes is definitely a bigger thing because you have to make sure you're calling the proper objects. A lot of times also, remember, we can do super calls inside of the equals and toString in order to kind of help make our life a little bit easier, and also in order to call those objects that may not exist within the derived class. Because remember, if we go back to the notes here on super, all right, remember the name and the date were parameters that were derived from the original object, employee. So I would have to do a super call within my equals and toStrings in order to get those values to be usable. All right, now, the important thing to remember, part of the reason why all this happens is that pretty much every object that we're creating are members of the object class. These are where these methods are coming from. And because they're part of the Java library, I don't have to, like, any way, shape, or form implement objects. Objects exist. But if I want to change how things work with like equals and toStrings, I have to create them within that class name. So I can't just compare the name of the variables. I have to, a lot of times, include what type they are, because they're not like an int, they're not a string, they're not a double or a boolean. So I have to go ahead and make sure I do that changing to the appropriate class. If you need the fine details on that, of course, you can go and comb back through your notes. You may not always need that. Of course, I also have some example programs that you can look at that are going to show those as well. All right, and that's it. Nice, quick, and dirty, easy one. You'll get some good materials here in the notes that'll help you digest things. But other than that, folks, buzzing right through this review, so I will see you next time.